I have completed my visual inspection of this array, and now I'm going to revisit the damaged module. And as we're showing, this module has been impacted, has a hole in it, and I also can see burn marks. This module is a fire and life safety concern, and it is recommended that it be pulled out of the array. Now, just to see how it's impacting performance, I'm going to open this box and take a look. I am now going to open the box, but before I do, I'm going to make sure I have my personal protective equipment on. I have safety glasses and I have my 1000-volt gloves handy. And as I open the box, I notice a very crucial thing. We have a wiring diagram of the array. I can identify exactly where the broken module is and in which string. According to our diagram, it's in string 2. And as I look at currents, I'm interested to find if there's going to be any degradation due to the broken module. So I'm going to start with string 1 and do a current clamp. And I'm measuring 3.2 amps. I now go to string 2. And I'm measuring 3.1 amps, or 3.2, depending on where I get it in my clamp. String 3 is a little more difficult to get at. You want to be careful as you're looking for clamps. I'm going to just jump to 4, and again we have 3.1 amps. So what I just learned is that though that module is damaged, it's still producing the same current as the other strings. Now, out of curiosity, let's see how we're looking voltage-wise. So I have my Fluke 87. I turn it to DC voltage, and I could do the same exact measurement, and it should all be the same. But this will tell me if I have any blown fuses. So I grab the negative bus, and I'm now going to measure on this side of the fuse. And we have 406.3. We're ranging because that's what the inverter is doing, as it's hunting for the peak power point. And we have the same voltage on string 2. So that tells me string 2's fuse, as the current did, is in place. Now, one thing I would like to do is do what is known as an open circuit voltage. Traditionally, we would disconnect this string before doing and then put it back into service. So in order to do so, I am going to stand up and go open the disconnect switch. And disconnect switch RDC1J is the disconnect that serves that combiner box. And to open it, you just throw the switch. What my determination is, the impacted module or damaged module is not bringing the array down. This string is operating within spec. However, at the module, and it's important, don't touch this module unless you have your gear on. At the module, I see hot spots, browning on that cell, and then I can see damaged cells in this area, and I can see through the hole. I know that when this module gets wet, it is going to pose a ground fault. And I actually can see signs of it right there. I can see some corrosion around the edge of the frame. And so it's actually imperative that this module be replaced. And that brings us to the process of replacing a module. It could be done pretty quickly if you happen to have spares. You're just going to shut down the array, as I've already shown at the combiner box. You're going to come and open each and every fuse in the combiner box as well. We have now isolated all strings from one another. Then you would get underneath the module into the wiring, and you would actually disconnect the module. And I can feel the wiring right here. The actual terminal box is here. So if you trace the wiring underneath it, you will find the disconnects. And the disconnects, here they are, I can see them. They're actually right underneath the module in this area. So you would remove those disconnects, unplug them, unbolt the module, set a new module, and then you would be done. If the modules are no longer available, let's say that you do not have enough spares, then what you would need to do is decommission the string, and then you would have the remainder of the modules you could use as actual spares. Now we're going to bring the system back online. It's going to consist of a 3-step process. Step 1, we will close all the fuses back in. Step 2, I will go and turn the disconnect switch back on. And then I'm going to come back here with my current clamp, and I'm going to measure currents and make sure that the combiner box is operating correctly. This completes our measurements of this combiner box. And there are some key takeaways that come with. Number 1, the impacted module, the damaged module, is not pulling down the performance of the array. Its current production is identical to the other strings in this combiner box. Therefore, the string monitoring would not have found this failure. It was only discovered through visual inspection, which underscores the need for thorough visual inspections of the PV arrays.